Well, happy Wednesday, everyone. Happy end of one 4-year era and start of another one. My name is Jennifer Abel, and I am the training coordinator for the Portage Network. And I'd like to begin by acknowledging today that the land I'm speaking to you from is the traditional, ancestral, and unceded territory of the Coast Salish peoples, including the territories of the Musqueam, the Squamish, and the Tsleil-Waututh nations. Today, we're here to learn about schema.org for research data managers. Data managers are currently investigating the value proposition of schema.org, or SDO, with a lightweight implementation that couples the SDO vocabulary with indexing Google Dataset Search. This pathway essentially webifies dataset search and syndication and enhances dataset discovery. This webinar's aim is to highlight current initiatives within the research data management community and the work currently being completed relating to SDO. To begin, we'll introduce the ITO's schema.org for research data managers, a primer, which leads into the current resources available in the RDM community, including the crosswalks collected by the RDA's Research Metadata Schemas Working Group and the user-friendly crosswalk visualizations, and finishing off with a synopsis of ESIP's SDO Science-on-Schema Community Extension. There were a lot of acronyms in there, but we'll get them all sorted out as we go through. A couple things to remind you of before we get started today. I've been muted automatically when you entered the webinar room. We are recording the webinar and the chat may be archived for those who are unable to attend. We encourage you to use the latest version of Zoom so that you have access to all of the features, including security updates. Please use the chat feature if you're having technical difficulties or if you have any additional resources to share. And please use the Q&A option to ask questions of the presenters. Questions will be addressed at the end. You may also raise your hand if you wish to ask a question. Questions may be asked in English or French. They will be answered in English, so I will do some translating for you, if necessary. We do have a code of conduct that we follow here at Carl and Portage, which you can find at the link on the screen or in the chat. Carl and the Portage Network are committed to providing a welcoming, safe, and harassment-free environment for its staff, membership committees, and working groups, as well as for participants, speakers, and organizers of Carl meetings and events. We don't tolerate harassment of any kind. And now to introduce you to our presenters today. Chantal Very is a research associate for the World Data System International Technology Office hosted at Ocean Networks Canada. So she's telecommuting to Victoria, but she's in Hamilton today. She has a Master's of Science in Environmental Management from the University of Reading in the UK and was dedicated to researching forest fire trends in the Canadian boreal forest. After her research was completed, Chantal moved on to work at the University of Waterloo as a data manager for the Polar Data Catalog. Now she's combining her research and work experience to investigate the usefulness of schema.org implementation as it attempts to open the discovery of datasets to a much broader audience. And Adam Shepard is the technical director for the Biological and Chemical Oceanography Data Management Office located at the Woods Hole Oceanographic Institution, where he's worked as a software developer since 2000. In 2019, he co-founded science-on-schema.org for helping the science data community describe their datasets for search engines. He serves as the chair of the schema.org cluster for the Earth Science Information Partners and is co-chair of the Research Metadata Schemas Working Group for the Research Data Alliance. Currently, his work focuses on data semantics for urban flooding forecast prediction and improved discovery and reuse of ocean science data. And now, Chantal and Adam, the virtual floor is yours.
Awesome, thank you. Let me set this off. First, I would like to acknowledge that the land on which I'm joining you guys on today is the traditional territory of the Haudenosaunee and Anishinaabeg. And then, okay. Can everybody see it okay? Is that correct? Yep, perfect. Okay, so first I'd like to say thank you to the Portage Network for welcoming us here and to speak to you all about schema.org for research data managers. Today, we will be going through quite a bit of different topics. First, we're gonna start with an introduction to set the scene. We will describe what schema.org is and exactly how it is established, the benefits of schema.org, considerations for implementation, community tools currently available, and then we will move to domain-rich extensions that are available, such as Science-on-Schema. But first, I would like to take a quick poll to see, so we can capture a sense of our audience. If we don't mind, it might pop up in a second. So it's what occupation or profession are you currently a part of? And then you have your 4 options. Perfect. Give you,
Sorry, I had a slight technical difficulty over here, but now we're good.
Yeah, that's perfect, as long as it gets up there.
Almost. Oh, 90% turnout. This is good.
Yeah, that's pretty good.
Give it a couple more seconds. Okay, I think we are where we're going to be.
Perfect. Oh, yeah, definitely have a good mix in there. It's nice to see that we have librarians as well as data managers joining, because that's definitely beneficial for both, as well as researchers and others. It's good to kind of get a sense of the landscape, right? So moving along. So through our research, we've established that data managers are at the vanguard of the open data movement. It's driven by the desire to ensure that our data assets are well managed and widely available to the research community and the public more broadly. So the RDM community has placed enormous emphasis for encapsulating the FAIR principles for data and the trust principles for data repositories. For a quick refresher, which may or may not be very repetitive for you all, FAIR principles promote activities that ensure data is findable, accessible, interoperable, and reusable. And the trust principles are of transparency, responsibility, user focus, sustainability, and technology. So semantic markup is a core technology we have at our disposal to ensure that data managers adhere to these principles. Data managers who are new to semantic markup may find the landscape baffling. We would like to drop the veil a bit and target data managers who need a simple, straightforward, and accessible introduction to semantic markup, beginning with schema.org, also pronounced or acronym used as SDO. So I'd like to take another quick poll to try and see which stage, or if any stage, you are all familiar with schema.org, and give it a couple seconds to for everybody to respond.
Okay, give it a couple more seconds. Any last folks want to? Okay, I think that's what we're going to get. So.
Oh yeah, that's definitely, it's nice to see that we have a mixed bag and that you've actually have heard of it. So we can at least have some sense of what we're going to be walking through. Thank you. Okay. So exactly what is schema.org for those who didn't know? Schema.org is a collaborative community activity with a mission to create, maintain, and promote schemas for structured data on the internet, on web pages, and emails, and beyond. So shared vocabulary makes it easier for webmasters and developers to decide on a schema and get the maximum benefit for their efforts. The schemas are a set of types, each associated with a set of properties. The types are arranged in a hierarchy. So it goes, the vocabulary currently consists of 778 types, 1,383 properties, 15 data types, 73 enumerations, and 367 enumeration members. So it's quite a lot packed in there. So the history of schema.org, I find it beneficial to starting with the semantic web before schema.org. So the idea of the semantic web long predates the arrival of schema.org. Tim Berners-Lee, the inventor of the World Wide Web, expressed a vision of the web as a connected set of data. So the goal of the semantic web is to make content on the web machine readable and actionable by making explicit connections between published content. As data managers and scientists with increasing volumes and variety of data to manage, discover, and analyze, it is imperative that we adopt semantic markup and related technologies so that we can automate our workflows. So schema.org is a specific example of the broader class of semantic technologies. And schema.org was created by the four major search engines. We have Google, Microsoft Bing, Yahoo, and Yandex. So what exactly are the benefits of schema.org? So first, it would be Google Dataset Search is the primary driver for repositories implementing schema.org in their metadata landing pages. Google Dataset Search was designed to do for datasets what Google Scholar did for publications, providing a single interface to search and view simple metadata records describing datasets from thousands of data repositories around the world. The natural appeal of both Google Dataset Search and Google Scholar stems from the user-friendly interface that Google creates, making it easy to go for finding content. Once a data repository has implemented schema.org in their dataset landing pages, they can become discoverable within Google Dataset Search. So it is important to note at this time, Google does not hold copies of the data itself. Users who discover data in Google Dataset Search are referred back to the repository to access the data. So where exactly does schema.org happen in a repository? Repositories have a database of metadata that describe their holdings. That set of metadata is used to either publish a harvestable metadata service and/or is used to generate a series of landing pages, one per dataset. The landing page is a web page generated from the database of metadata and includes a pointer to the data resource that can be found at the repository. And then the landing pages are marked with schema.org terms and indexed and included in Google Dataset Search. Importantly, for those who manage sensitive or restricted data, which are subject to privacy concerns, as noted, the user is then directed back to the original repository. So the access restrictions and protocols for data sharing follow what was agreed upon during the submission process and are maintained at that repository. So the basic premise of the semantic web is that one person publishes content and the terms used to describe that content are defined in an online semantic resource, so a dictionary, an ontology, or a list of controlled terms. The semantic resource must be online and open to parsing by machines. For data managers, this opens the possibility of machines being able to identify, compare, and conflate and process data. In our case, Google Spider can crawl over a set of data set landing pages, collect all of the titles, abstracts, and location information for each data set, index them, and open that index up through Google Dataset Search. So this process is to enhance a repository's interoperability fairly easily. Schema.org supports 3 different mechanisms or formats to add vocabulary terms to a web page. This is microdata, RDFA, and JSON-LD. Both microdata and RDFA are a set of tags and HTML extensions that are embedded in line in a web page next to the text it defines. There are technically only 2 terms of tags that are required as part of a dataset description to be included in Google Dataset Search, and these are name and description. There are additional terms that Google recommends you include as part of your metadata markup, including, but of course not limited to, dataset creator, download information, unique identifier, license, and variables measured, although the records may be still available in Google Dataset Search without the additional tags. So some considerations. It is the first step towards a common language for data on the web. It's aligning semantic markup across domains for data managers. Schema.org serves at least 3 functions. It immediately opens up your data holdings to a wider audience via Google Dataset Search. It is a high-level, simple introduction to semantic markup and serves as a gateway to more complex ontologies and workflows. It is a good starting point for aligning ontologies and by extension our data sets across domains. Although schema.org is a very, very lightweight ontology and it is left to the domain-specific research communities to develop more expressive ontologies that adequately describe their data sets. So data managers often use multiple ontologies to annotate or mark up documents like metadata. Many hope that they can use a handful of common terms from schema.org like title and description and reference other ontologies to capture more domain-specific knowledge about their data sets, which we will discuss further in a bit with Adam. To the extent possible, even when developing domain-specific ontologies, the best practice is to reuse terms from well-established and well-shared vocabularies. So although no matter what the domain, it is best practice to reuse vocabularies before you build your own. So if you're looking for vocabulary servers, we recommend basic Register of Thesauri, Ontology, and Classifications, where you can search for both vocabularies and semantic registries. Also, Fair Sharing, an RDA-endorsed repository which promotes a curated, informative, and educational resource on data and metadata standards interrelated to databases and data policies. To further enhance established ontologies, mappings can be developed between prominent ontologies that can serve larger communities and support interdisciplinary research. For example, if a repository can easily detect terms between ontologies, these overlaps are used as they can be used by developers to identify and create formal mappings. The creation of controlled domain-specific vocabularies is fairly labor-intensive and requires quite a bit of collaboration from within scientific communities to reach a consensus on which vocabularies should be used and included in the extension and how they should be implemented. The important message here is to avoid reinventing the wheel. If domains can look for guidance from other communities that already have established a step, it can make everyone's workload a little bit lighter. For example, established vocabularies such as the robust set of paleo-environmental standards terms passed from the paleoclimatology community and the medical subject headings, MESH, from the National Library of Medicine are important pillars in scientific semantics. So speaking of not reinventing the wheel, the Research Data Alliance has created a set of crosswalks which have already established which terms are widely used in the RDM research data management community currently. This specific working group has established and is currently in the process of establishing their deliverables, which are threefold. First, the working group deliverables include from output 1 is data model, a generic conceptual data model with essential types and properties from research data discovery of the web. Output 2 includes producing a guidance document, which is a guideline illustrated with common patterns for publishing metadata landing pages with structured data markups, and a guideline on how to customize the research schemas for target domains with examples. Output 3 includes toolings for making the implementation easier if resources are available. So specifically to this webinar, we will explore outputs from the first deliverable with the current collection of crosswalks and the ITO established crosswalk visualization site. So welcome to schema.org crosswalks. In order for transparency, the crosswalks adhere to the EOS Secretariat guiding principles that semantic artifacts should be available in repositories and must have sufficient associated documentation with clear examples of usage and conceptual diagrams. The crosswalk roadmap to be created in 2021, so that should be coming, in addition to the metadata that they maintain records of tools and crosswalks. So currently we have we collected about 15 metadata schemas mapped. This includes ISO 19115, code meta, space, bio schema, and you can see the rest are up there. The link to the crosswalk visualization site is at the bottom of the slide. Feel free to head over and play around with it whenever you get a chance. The crosswalks are currently being hosted in a community managed Excel sheet. The sheet can be a bit overwhelming, and the visualization tool created is a great way to explore the information in the crosswalks and a user-friendly interface. So I'll be quickly going over exactly what the crosswalk visualizations entail and the different viewpoints that they offer. So the first one that we have is the filter table. It's a schema filter table, provides a one-to-one mapping of metadata terms to schema.org, utilizes the top level of schema.org, identifies any missing terms from the schema or from the schema.org suggested terms and with no current mappings, and filters by one of the 15 metadata standards. The second we have is the search table. This one is a bit more interactive. So a table is a free text search over both metadata and schema.org properties. The table will pull a related metadata term for associated property searched. For example, a search for publish will not return records, but the search for publish will return date published, publisher, dataset publisher. And this table includes the metadata standard, the metadata term, the schema.org parent type, and the schema.org crosswalk. So the next is the Sankey diagram. Our Sankey diagram emphasizes the major transfers or flows within a system. This filter allows you to choose a schema.org property and see which, if any, crosswalk term is connected to which standard. So from left to right, it goes the schema.org property, the crosswalk term, the metadata standard. This visualization allows for you to hover to see the flow in more detail, and it gives a great visual for more commonly used mappings. And lastly, we have the gap analysis. So our gap analysis gives a visual representation of terms within the metadata standards that did not have a schema.org property. By hovering over the metadata standard name, it will display a numerical value of missing terms to give a sense of how robust the metadata terms have been mapped to schema.org properties. So we recently presented in the last RDA plenary, we received some constructive feedback that we are investigating if we are able to implement on these visualizations. So the first feedback was a gap analysis. Some individuals wanted to see commonly missed terms, not just filtered by standard, rather the actual term. So we were looking into expanding that and possibly expanding the Sankey diagram with a pop-up window to replace the hover feature. So also currently being wrapped up is assessing the home for crosswalks. Currently, our plan is to have them preserved in version to adhere to the EOS Secretariat principles, as previously mentioned, ensuring that they have the proper documentation assigned. So our original investigations included RDA endorsed fair sharing, ARDC, U of Bath. We are looking for a home that is willing to host the crosswalks and possibly update them. The ITO office is willing to be a part of a committee or working group to update them, but not looking for solo control. As of right now, the plan is to capture a static version of the crosswalks in Zenodo and add the collection of fair sharing. And the second part of the crosswalks are the visualizations, which are currently being hosted at GitHub, but they will be promoted and maintained through the ITO office and website. So I've gone over quite a bit of information in regards to the basic level schema.org implementation. I would now like to hand it over to Adam, who will be able to go into more depth about the Science-on-Schema extension.
Thanks, Chantel. Hey, everyone. Thanks for having me as part of your webinar here. And I want to talk about science-on-schema.org. And this was an effort that came out of the data management repositories in the US, sort of responding to this flood of web publishing patterns that we were seeing coming out of Google and Bing, and just wrestling with that struggle between, pumping out metadata for DOIs and ISO records and all this other metadata that we generate for scientific data sets. How do we sort of mesh the two together so there's not like this duplication of effort on the data manager side, but letting those data repositories really benefit from these web publishing standards like schema.org. And so we sort of sit in between the science metadata or the publication metadata that you typically get out of libraries and data repositories, and sit in between that and sort of like these new web publishing standards like schema.org. And the idea there was really to just sort of have shared patterns across data repositories and libraries, so that we were all using schema.org the same way, and hopefully being able to leverage the metadata work that you already do in the office. And so that was the idea behind this science-on-schema.org. And we can move to the next slide. And, really it came down to this idea that, well, Google and Bing can sort of scrape the web and grab all this markup in the HTML pages. That's great, but it's an open framework, and so anyone can scrape that data and information. And so we thought, wow, we can do this for our geoscience repositories and have almost like a geoscience data repository search in that regard. And so that's where these sort of like shared common publishing patterns for schema.org and our metadata really became important, because it meant that if we were using the same patterns across all of our repositories, we'd have reliable, consistent harvesting of that metadata for federated search. So that was one benefit. And then the other was this other benefit, which was that you could then automate validation of the markup. And so if you were translating your DOI metadata into schema.org or your ISO metadata into schema.org, we could write tools against these shared publishing patterns that would tell you, like, hey, here are the fields that work right out of the box, or here are some of the fields that might need some tweaking. And all this is really just driven by making it as easy as possible for the data managers to engage this schema.org movement by leveraging the work that they've already done. And let me know if I'm going too fast. If y'all have questions, just pipe right in. Okay, so yeah, we can move to the next slide. And so really, schema.org has their own website, and they're publishing their own guidance. So why do we need one specifically for data repositories? Like, can't they just go to schema.org in the browser and figure it out for themselves? And that would be great, but there's a couple limitations that we felt looking at schema.org as a website. And the first one is that there's a ton of patterns that you can publish. So there's a lot of options to pick from. And we really wanted to help users sort of navigate those options and mind map the concepts at schema.org to things that they're already familiar with their metadata work right now. And when you go to schema.org, it's flat descriptions, and it's really hard to get a sense of how things are connected and limited examples. And so we really wanted to make it visually easier to understand what is going on when you're looking at schema.org recommendations. So we decided to go ahead and make some guidelines of our own that sort of annotate the schema.org publication there. So we can move to the next slide and just kind of quickly show you what we try to do on science-on-schema.org. And that's really just sort of give you way more examples of how to actually publish this stuff for your web people. So go down and knock on their doors, or I guess you can't knock on their doors now, but you can knock on their virtual doors and say, hey, go check this out and go do this for me. So we give you code examples, but also drawings that kind of help with those mind maps of concepts that you're probably already familiar with in the metadata that you generate now, and how they link together in the schema.org realm. So yeah. We can pop to the next slide, and I can just talk a little bit about the work that we've done. So it's the group that meets and sort of governs this. It initially started out as two folks, myself and another developer that worked for a data repository. And we built this in the span of like 6 months, and we're feeling very conscious about the work. We're like, oh gosh, we don't know if the world should be trusting us with these decisions, and we wanted to make sure that other folks had an opportunity to weigh in on the decisions that we had made. And so we took the guidelines that we wrote and transferred them over to this open Earth Science Informatics community called ESIP, which stands for Earth Science Informatic Partners. And there's a group there that sort of governs these documents. We've had some great participation, and just as an example, this past April, we published the first update to the guidelines that with the initial developers wrote. And there were 7 contributors to those guidelines, and we made modifications on how to describe persistent identifiers like DOIs and ARCs and things like that. Made modifications to describe dataset licenses, and then how you might distinguish a digital representation of metadata versus data files that are described by those metadata, and a couple other things there. But yep, and so as you can see, we use the GitHub platform to publish all this stuff. We really haven't gone through the heavy lift to like generate our own website or even use the GitHub pages, because we really wanted this to be something that the community decides. And so if the community's behind it and wants those things, then yeah, we'll do it. But we didn't want to like go ahead and do all this work and make it this huge effort for the community to sort of jump in and tackle it. And so we've just sort of let the science-on-schema.org grow organically. Okay, so I'd like to, in the next slide, just sort of give you a little bit of information about this ESIP group. And so there's a schema.org cluster at ESIP. And what that group does, essentially, they meet twice a month, and we monitor the monthly updates that happen at schema.org. So, Google and Bing and Yahoo, all those folks are making these decisions. And those decisions are open on GitHub as well. And every month they sort of publish out this manifest of monthly updates. And so we monitor that for things that might impact how we describe data sets or data repositories. We also accept contributions and issues at that GitHub repository. So if you go to science-on-schema.org, it'll redirect you to GitHub. So feel free to chime in there and ask questions and make fun of us and suggest additions to the guidelines. We're an open community and we don't take ourselves too seriously. So we want community feedback in that way. Yeah, and so we just maintain this resource, and so far it seems to be really helpful to the community. And just to give you a couple statistics, in that first 6 months that we had the guidelines, we had 13 data repositories take that and implement it right away. And so we felt like that was a good measure of how easy it was for web developers and your data managers to sort of take these guidelines, understand them, sort of make that connection between the metadata that they already generate and what Google and Bing are looking for in the schema.org markup on the HTML pages. So we hope that's an encouragement to you to sort of look at this effort to make sure that your data sets are more easy and better described on the web to find. Yeah, and so we invite everyone, please hop into this community if you're interested in sort of steering how the guidelines progress over time. I have a little picture of Steve Irwin in there. I don't know why. For some reason, he was an inspiration to us because we felt like as data managers jumping into that pond, it was like we were in a jungle and really had to figure our way through what schema.org was. And we hope that we've done that for the science data sets with science-on-schema.org. So thank you very much. And you'll find details about how to connect with ESIP at the link there, or feel free to drop me a note by email or ask questions here. So thanks for your time.
Awesome, thanks, Adam. Definitely loving the Steve Irwin photo. So that was a good ad. So yeah, thank you for joining. And I would like to say to everyone interested in the Science on Schema cluster, the cluster is a fantastic group to sit in on, and they are more than welcoming to individuals, as you can see Adam is. So even if you're new to the community and you're just willing to learn, it's nice to just even sit down, and listen to the discussion that's happening. So before we move on to questions, I wanted to mention a couple of resources that are about to be released to the research data management community. So the first is the how to use the RDA crosswalks and crosswalk visualizations for the actual markup. This is going to be published of March of this year. It's a step-by-step. So the IT office has created a step-by-step document outlining how to identify which terms to mark up for your own metadata, and if there is not already an existing crosswalk for your standard. For example, we used it to recommend markups for the CDAC organization as they use a proprietary metadata standard. And like I said, will be published by March. And also currently in our second draft is our schema.org for research data managers, a primer. So this document ultimately goes into, takes information from this webinar one step further to give the reader a better sense of the current landscape. We're possibly looking to create a lightning version as well and host it with the SDO cluster. And it's to be published by March, but we're open to hosting suggestions if anyone knows or wants to suggest a suitable journal. These documents altogether should enhance guidance documents for the actual schema.org markup. So please find our contact information if you have any pressing questions or if you would prefer to talk to us later. We would like to thank the Portage Network again for hosting us and for giving us a platform to talk to everybody about schema.org. And now, if I'm not mistaken, we can go to questions.
We absolutely can. Thank you, Chantal and Adam. A reminder that if you have a question, you can put it into the Q&A box or you can raise your hand. And we have one hand that is raised now, which is Jane Fry. And Jane, you should now be able to unmute yourself.
I'm not sure why my hand is raised, because I didn't hit it intentionally, at least. But I did want to say that I did find this most interesting, and especially the RDA stuff and the visualizations. And I'm definitely going to play around with that website to see all the different things that are in there. So thank you very much.
No problem. I'm glad that you're interested. I was the one to update it most recently. So if you find any little technical errors, feel free to send me an email. Keep me posted, please.
Great.
Yeah.
Okay, so we have a question in the Q&A from Kevin Lindstrom at UBC, who's wondering, since many researchers are uploading their data sets themselves and are creating their own metadata, how can we encourage researchers to use schema metadata or vocabularies?
That's a fantastic question. I think that letting researchers become aware of the certain tags and certain vocabularies that would be beneficial for their metadata is a good start. Having them at least kind of be aware of the landscape is, I guess, the best way to do that. And then from there, the individuals who are managing the repositories are able to maybe make those matches a little bit easier. But I'm not sure if Adam has would like to add or anything to it, or what?
Yeah, that's a challenge. You know, I think from the science-on-schema.org perspective, we were starting with the library or data repository perspective and didn't really get a chance to tackle individual researchers. Certainly there's tools out there, and I think we list a couple of them on the science-on-schema.org website that'll help folks sort of populate that information, but you know, it really needs to be embedded in an HTML page. So I'm not sure if the researchers are managing those HTML pages. But if those researchers are getting DOIs, and especially if they're getting them from Datasite, I know Datasite is already generating schema.org for them. And so that would be one way to encourage them, yeah, to not only get a DOI, but have it be discoverable in this way for Google and Bing. So I hope that's, you know, a halfway answer.
Yeah, and I'll note that we have a comment from Chantal Ridsdale as well, that one way to get buy-in from researchers is that citing the benefits, so reuse potential and discoverability, which leads to citations, could go a long way. And I think that's a good point as well.
Yeah, go Chantal. Our regulars at the schema.org group there. So it's great to have her here.
Other questions? I might ask a question while I'm waiting for other people to ask questions. Because a lot of what we're talking about is making things discoverable on Google and Bing and websites like that. Is there any reluctance from researchers to have material discoverable on Google and Bing?
Boy, that's
that
a
you've
good
heard?
question. You know, operating a data repository in the States, you know, so we're just looking at how people find our repository and data there. We've seen this shift in the metrics of them not coming to us to start their searches, but just searching in Google.
Right.
And so I think we took that as, gosh, this is something that we need to engage in to make sure that they're finding the right data. And so, yeah, we could give a number of examples of things that they could type into Google that like sends them to our site that wouldn't be what they want. And so we just wanted to make sure that we were engaging in that process. But that's, Jennifer, that's a great question. I don't know if Chantal has thoughts on that, but we haven't heard from our community that they wouldn't want that.
Yeah, from my understanding, I would say it's more of a positive response from researchers that at least I've interacted with, that they would prefer to have it as discoverable as possible. But of course, that's kind of, I guess, leaning towards the open data. Like, this is not touching on the data that has the privacy concerns or anything really special that they don't want shared. But like I said, Google Dataset Search does redirect to the original repository. So if anything, I think it's positive to give that original repository who's hosting the data the exposure as well.
Great, thanks. That's an interesting way to think about it, yeah. A question from Phil Barker, mostly for Adam. Is your guidance encoded in any machine readable format, like a couple of ones that I'm not familiar with, Shex or Shackle, to allow automatic validation?
Yeah, that's a great question, Phil. So there is a fellow in our group named Dave Vieglis who wrote a number of shackle shapes to check against our validation, and he published that as a Chrome plugin. So you could navigate to a page in Chrome, run the tool, and it would tell you, how well that page, validated against the current science-on-schema.org guidelines. I don't know if he's made those shackle shapes public, and so I think there's a GitHub issue in there about that. But if not, and that's important to you, please drop that in there, because I think that was his intent, that the group would publish out these shackle shapes so that others could just use this right in their own environment, so PyShackle or whatever. But yeah, I know there's a Chrome plugin. If you go to the extension world in Chrome there, if you search for science-on-schema.org, yeah, you'll find the tool.
Thanks for the great question, Phil. Any other questions? Going once. Going twice. All right, seeing no further questions, and usually when I say that, someone asks one, but it doesn't happen. There we go, it does not happen today. Again, I'd like to thank Chantel and Adam for their presentation today. A reminder that if you have any questions for them, you can get in touch with them at the links that you're seeing in the slides, which I will be sending out to everyone along with a link to the video probably in the next couple of days. A reminder that we have a survey that we would love you to fill out to let us know how you found the webinar today, both literally how you found it and how you found it as an experience. And coming up in a couple of weeks, we will have a couple of webinars about the launch of Furter. You've probably gotten some emails about that through various networks. If you haven't, you can drop me a line and I can tell you more about it. But in the meantime, enjoy the rest of your Wednesday, and thank you again, Chantel and Adam, and thank you everyone for coming.
Yes, thank you so much, guys.
Thanks, y'all. Have a great day.
You too.